Okay, welcome back. So in this video I'll be talking about the work done by an object when a force F is displaced in an object to a distance d from its initial position. So work done. Right? Work done. Now I'll take a simple horizontal surface like this. If an object is like this, it has some mass and the mass of the object is irrelevant to the force and the displacement it takes. So I'll put some force here. I'll put some force here which is theta degrees angle to the horizontal. So this is the horizontal direction, and with this force, this object I will take, it moves the same force at this point as well. So what actually happens is I am putting this force this center so that the line of action inside the center of mass. This is the center of mass. So the displacement of this object is how much? The displacement of this object is how much it is the center of mass is displaced across this horizontal surface. So this I will take as d, the horizontal displacement. So if it has force F in this direction, it will have some force F cos theta. And in this direction, it has force F sin theta. So assuming that the object doesn't move in the vertical direction, I will take only the movement of the object in the horizontal direction. I can say that the work done is the multiplication of the force in the direction of the motion times the displacement in the direction of motion. So the force and displacement should be in the same direction. So W equals F cos theta times d. So this is a very important derivation. W equals F cos theta times d. So the work done by a force is equal to its product of the force in the direction of the force and the distance, so that the force and the direction of displacement are in the same direction. So W equals F cos theta times d. So for most of these occasions theta equals 0, so that the force is horizontal. So if theta equals 0, we will get the popular derivation W equals Fd, because if theta is 0, cos theta is 1, so W equals Fd. So W equals Fd. Now what happens if an object, this is moved in this horizontal plane from here to here, say this has force 20 newtons. The displacement of the object is 5 meters. So the work done by the force is Fd. F is 20 newtons. Now we have to consider whether the force is in the direction of the displacement of this object. So the force is already on the direction of the displacement of the object. So we don't have to decompose into the horizontal and vertical components. So the force is 20. And the distance is 5, so this is in newtons times 5 meters. This is 100 newton meters, which is also sometimes called 100 joules. So the work done by this force, work done by a force of 20 newtons when it is moving a distance of 5 meters on a horizontal plane is 100 joules. Alright, so if I select another example in which the object is initially at rest, this is 0 meters per second, and if I put a force here F, so this is a force, this is a velocity, right? Actually, if you are confused, don't draw the velocity here. Velocity, normally we draw the forces by arrows, either in the positive, either in the horizontal direction or the vertical direction. If you are confused, you can draw the velocity object outside this object. So the same force will act at this point as well. The force is a constant. I will take the velocity due to this force. Now the object is initially at rest, and it moves a distance of, I'll take it as some 10 meters. Yeah, 10 meters. 10 meters. And if the object has mass 2 kilograms, object has mass 2 kilograms, so the force is constant, so the force that acts at a distance of 10 meters away from the initial position is also F. And I'll take the velocity to be 10 meters, 30 meters per second. So what is the force F? If there's a question like that. So you know that W equals Fd. So work done by the force is F times D. D is 10. So work done by the force is 10F. But you don't know the value of W to find F. But you know the value of M and the change of V. So you know that by the conservation of conservation of energy, considering that the motion of the object is not converted to light, heat or sound energy or any type of other energy, the total work done by this force is converted to the increase of kinetic energy. So the increase in kinetic energy delta K is equal to half times m Vf squared minus Vi squared. So Vi is 0 because the object is initially at rest, so Vi is 0. So the total kinetic energy, total change in kinetic energy of this object is equal to the kinetic energy at the final position. So we can assume that considering that the energy doesn't convert to light, sound or any other form of energy, the total work done by this force was used to increase the total kinetic energy of the system. So Fd, F times 10 is equal to the increase in kinetic energy half times mv squared, half times m is equal to 2 kilograms, v is equal to 30. Now v squared minus u squared, u is equal to 0. So only v squared is taken, so this is 30 squared. So 2 times 2, this is cancelled. So 30 squared is 900, 10F equals 900, F is equal to 90. So a force of 90 newtons, if it is acting on an object of 2 kilograms, and if the object is displaced distance d, on the other hand, it will experience a velocity of 30 meters per second. So in this video, I explained what is meant by work done by a force. Now we generalize the concept of work done by a force that is inclined or angled to either to the horizontal horizontal direction towards the vertical direction. So we took the normal condition of W equals Fd cos theta or F cos theta times D, but in most cases we take theta equals 0 or the force is parallel to the horizontal direction or in the horizontal direction. So we took theta equals 0, so cos theta equals 1, so W equals Fd. So for a force that is in the direction of displacement, W equals Fd. So we solved 2 examples regarding that. So in the next video I will be talking about the work done by a force under some special conditions. So I hope that you enjoy this lecture and you get some information. So thanks for watching this video, and I will see you in the next video.